I wanted to do a couple of quadratic function examples. I'm going to take a quadratic function of each form and kind of run through all the different things you might be asked to do with it. So let's start with a quadratic function that's in the ax squared plus bx plus c form, one that looks like this. And let's just kind of make sure you understand how to graph it and do all the other things they might ask you to do. So one of the things they might want is for you to graph it, okay? And so when they want you to graph it, it helps to find some of the key features of the graph, okay? So what you might do first is notice that in front of the x squared term that you have a 1. So if a equals 1, you know that's a parabola that's going to open up because it's a positive number. All right, another thing you can do on this pretty quickly is go ahead and notice that c is -5, which means you know the point 0, -5 is going to be on the graph of that parabola. All right, with this one, you could find x-intercepts by letting y equal 0, which means you just need to solve x squared minus 4x minus 5 equals 0. And this happens to factor, so you could factor it. You could set each factor equal to 0 and wind up getting your two x-intercepts. One of them's over here at 5. One of them's over here at -1. So you know that those are the x-intercepts, and you know the y-intercept is -5, okay? All right, but one of the features that really helps you get your, let me write this, that's y-intercept. One of the features that really helps is to find the vertex. So the vertex is that point right there, you know, where the function turns around. All right, and in this form, one of the things you're learning about is that to get the vertex, you use the first part of the quadratic formula, the -b that's on top and the 2a that's on the bottom. And then once you find that, you just plug in that number, and that'll tell you what the y coordinate's going to be. So b is -4, so you're going to have the opposite of -4. A is +1, and so you know the x coordinate of your vertex is 2, and you can kind of tell that it's going to be over there at 2. Then you come back in and you plug 2 in for the x in the formula, and you work that out, and that's going to be 4 minus 8 minus 5. That's going to turn out to be a -9. So you know the vertex is 2, -9. So this right here, okay, which is trying to be a vertical line, that vertical line at x equals 2 is the line of symmetry. And then what you just found out is 5, 6, 7, 8, 9 is that the vertex is there at 5, 6, 7, 8, 9, at 2, -9. So that kind of tells you that this parabola is going to come in, curve around, come back up, and it should be basically symmetric about this right here. So that's your vertex. That was the 2, -9. Okay, and these were your x-intercepts at 5 and -1, your y-intercept at -5, and then this is called the axis of symmetry or line of symmetry. And it's always a vertical line. Since we're dealing with a function, it's always a vertical line through the vertex. All right, so sometimes the question that you're going to see in homework or maybe on the test will be just to graph a parabola. All right, but sometimes they do this. Okay, so let me get to a new sheet. So sometimes they'll want you to just take a quadratic function. So we'll start with that. So this is the second thing they might ask you to do. They might just want the vertex of something. So they might just want the vertex of your quadratic function. So we had x squared minus 4x minus 5. And we already found the vertex, so you kind of saw how to do that. If you see that they want the vertex, then you should be thinking, they want -b over 2a, and then whatever the number is. So you would go through that work like we did. You'd get the x coordinate of the vertex is 2, and then you'd plug that in to find the y. And we did that. We found out that was -9, and then you know your vertex, okay? But the reason they want you to find the vertex is sometimes they want to know something about whether you have a max or a min. So do you have a maximum or a minimum? Minimum. Okay. So, when you think about it, you're going to have a maximum if your parabola opens down. You're going to have a minimum if your parabola opens up. So you found the vertex, but they might ask you, is it a max or a min? So you have to think about that a value again. And in this example, the a was 1, so your parabola opens up. So the vertex is a minimum. Okay. Now, what they might say, or the kind of language you might hear, is that you have a minimum of -9 at x equals 2. That's sometimes the wording that you hear. Okay. So if you ever see words in a problem that talk about maximum or minimum, you should think vertex. Okay. Right. And then there's one more thing that a vertex helps you with, and that is determining the range of a quadratic function. Now, the domain of any polynomial function is going to be negative to positive infinity. Polynomials are just, like parabolas, or they might have all of that, but they're nice continuous functions and there's no gaps or places where it stops. So the domain's not very interesting on a polynomial, but they really a lot of times ask you for the range. Okay. So like this one we know opens up, and we found the vertex to be 2, -9. So the vertex, when you're asked for the range, you need the vertex. So if you didn't find it earlier, you would look for that, and then you can kind of see that that's the lowest point. And so on this one, your range, your y values would go from -9 on up. Okay, so I wanted to do this problem. This is one where the problem is in that ax squared plus bx plus c form. Wanted you to know how to graph it, but also when they ask you questions that are related to the vertex, how to do that. Okay. All right, one more thing. Well, I think I'll stop there on this one, just getting the graph and the vertex. Okay. And then I'm going to do another video with the function in the other form. Okay, so let me stop.